Okay, so today we're going to look at resonating tubes. And like I told you in the last video, there are two different types. There's the open tube, which is opened at both ends, like what I have drawn here. And there's the closed tube, which is open at one end and closed at the other. So first open at both ends. And if you printed out the notes that I put up in the group for you, in Teams for you, there's a sheet that has these on it, and I haven't drawn anything in. I've just left it as this. So remember what we said the last day when we were talking about tubes. When they're open at both ends, when they're open at an open end, there has to be a node. So we want to create a standing wave in this tube. And for each case, there has to be a node at each end because both ends are open. So in the first one, we want to get the smallest possible number of half wavelengths or wavelengths, the smallest amount of wavelengths that could create a standing wave. That has to go between a node, and that would be a half, right? It would flip back and forth between a crest and a trough. So the L here, this is L. The L then is equal to 1/2 lambda, or lambda is equal to 2L. Okay? So if we knew the length of this tube, we could easily find its lambda. And since we know that V is equal to F lambda, and we could then rearrange and solve for F. So F1, this first tube, would be equal to V over lambda. Okay, and since lambda is 2L, then F1 is really just equal to V over 2L. And this is known as the fundamental frequency. The fundamental frequency. It is also called, for the musicians among us, the first harmonic. Okay, so F1 is equal to V over 2L, the fundamental frequency or the first harmonic. So now we want to find the next one. We want to find the second harmonic. So what's the next standing wave that could occur here? Still has to have a node at both ends, so we could add a half wavelength. And it could form a standing wave. Now, L is equal to 2/2 lambdas. In other words, lambda is equal to L. So all we did was add in a half wavelength. Okay, and so if we go to our equation then again, F2 would be equal to V over lambda. And in this case, F2 then is equal to V over, and I'm going to write it as 2 over 2L. And I'm going to do that just because I want to get F2 to equal, oh, well, maybe I'll do, oh no, I better do it down here so I don't go to the next one. 2V over 2L. And the 2V over L, oops, I did it the wrong way, shoot. The 2V over L, this 2L, the V over 2L is really F1. So F2 is just equal to 2 times F1. So what are the important things here? The ones I've boxed. The stuff in the between is just me showing you that if you want the second harmonic, which is what this one's called, all you have to do is multiply the first harmonic by 2. So this is called the first overtone, or the second harmonic. Now we go to the third one. What's the next standing wave? It's going to be 3/2. So L is going to equal 3 over 2 lambda, or lambda is going to equal 2 over 3L. Okay, we're going to fill it in again. F2 is equal to V over, and for lambda we're going to put 2 over 3L in, dividing by a fraction. Whoops, that's a 3. Dividing by a fraction is the same as multiplying by the reciprocal. 3V over 2L. There's that V over 2L again. F3 is just equal to 3 times F1. For the second harmonic, or excuse me, second overtone, third harmonic. Anyone want to take a guess at what the fourth harmonic is going to equal? Add another half wavelength. So each time we're just adding a half wavelength. Whoops, I should have made that one dotted. And so L is equal to 4 over 2 lambda. So lambda is equal to 1/2 L. Okay, if we fill this in, VF4 is equal to, I probably should leave it as 2 over 4 because it's going to screw me up down here. It's going to be V over 2 over 4L. So it'll be 4V over 2L. There's the V over 2L again. F4 will be equal to 4 times F1. The third overtone, the fourth harmonic. Okay, so I'm showing you all this to just show you where it comes from. What do you need to know? You should know the diagrams that you start with. For an open tube, you start with a half wavelength and just add a half wavelength as you go up each step. And from that, hopefully you can see what L and lambda are. And then know how to get your F1, and then know you do times 2, times 3, times 4, times 75. All right, time for closed tubes. Closed tubes are a little bit different because they're closed at one end, which means they need to have an antinode at that end, and they're opened at the other. So the smallest standing wave that we can get is not a half wavelength, it's a quarter. So again, if this is L, L is going to be equal to 1/4 lambda, and lambda is going to be equal to 4L. So when we go to V equals F lambda, F1 is equal to V over lambda, our equation for our fundamental frequency for a closed tube will be V over 4L. Box this guy, box this guy. So for a closed tube, this is my fundamental frequency, also called my first harmonic. Okay, the next one needs an antinode here and a node here. The good news, you're going to add a half wavelength again. So this time, L is going to equal 3/4 lambda. Lambda is going to equal 4 over 3L. And we're going to do exactly the same thing. So F2 will equal V over lambda, which will be V over 4 over 3L. So F2 will equal 3V over 4L. And there's that V over 4L. So this F is equal to 3 times F1. What? 3 times F1? It's not an F2 then. It's an F3. F2 doesn't exist. You can't have 2 quarter wavelengths because you need an odd number because of that antinode. This is the first overtone, or the third harmonic. Harmonics always match the number. That's why I like them better than overtones. For the next one, add another half wavelength. So we have L is equal to 5/4 lambda, or lambda is equal to 4 over 5L. Which means this F is going to be V over 4 over 5L, or 5V over 4L. There's the V over 4L again. This F is 5 times F1. It's F5. It is the second overtone, the fifth harmonic. Want to guess at what the next one will be? It should be L is equal to 7/4 lambda. So lambda is equal to 4 over 7L. And we'll get down to F is equal to 7V over 4L. So F is equal to 7 times F1. It is the seventh harmonic.